Okay, good morning and welcome to the workshop today. My name is Mark Brakey, KB7RHI, and I'm going to be talking about how you can add solar power to your station. You may already have your battery, or you're thinking about getting a battery, a solar panel, and a charge controller. So we're going to start off looking at the power needs of your station. We'll look at batteries. It's going to be rather basic coverage for a while in batteries, and then I might get into something that you haven't heard before regarding the LFP batteries. Then we'll talk about solar panels and charge controllers. That's kind of the core concepts that I want to cover. And then there'll be other classes. There'll be water, sanitation, peer-to-peer, and overnight, and antennas. That's going to be coming up more in the afternoon. Okay, so the primary questions we want to ask ourselves is how much power does my radio station require? How much power can my battery supply? And the big one that's the mystery that I'm going to help answer is how much power can I get from solar? So the 4 steps we want to do: how much for my radio, battery, solar panel, charge controller, and putting it all together. When I get to solar charge controllers, I'm actually going to go into a lot more detail and make the mystery of charging batteries a little less mysterious. So the first steps we need to know for our radio is what's the voltage range of my radio? How many amps do I need when I click on the mic? And how much energy would I need if the grid was down and I had to go for 24 hours and keep going day after day? Now these slides, by the way, will be available on the SEA-PAC website sometime in the next number of days, I believe. And so if you see something on a slide, you will not have to take notes for that. Okay, so we want to check the specifications for our radio. A lot of our radios will have a voltage requirement of 13.8 volts, and it'll say plus or minus 15%. So the low voltage that I need my battery to at least do is 11.7 volts. And then some of our radios actually get a little cranky if it's plus or minus 10%. And so if my battery voltage drops down below 12.4, my voltage minimum, it might not behave very correctly. So I would recommend that everyone who's serious about solar power get some type of an inline meter, a 12-volt meter. The one that I like the most is the RC Electronics. It will come with no Anderson power pole connectors. You have to put your own on. And the 30 amp is the nice variety. And this I'm going to talk about a little bit. There are other ones that are lit that have more light, but I find that out in the sun it's harder for me to read those. Okay, so this meter actually will show amps, volts, and watts on a continuous display, and you'll have a picture here more in a moment. And then it has another corner section that actually is a display cue, and it walks through some different readings about every 2 seconds. So here's what the meter looks like a little bit more. And I think if I can come over here. So this is our amps. There's our volts. There's our watts. And this will be the display cue that keeps changing and changing. And you might not be able to see it as well, but on this slide, the word source is right there, and the word load. And so what you want to do, if you want to be able to know how much current there is, here's the source side, here's the load side. You'll have to have your source here, load here, and it will show how many amps is going through. Now if you get it in reverse, it's not going to hurt anything. You just will see 0. But let's say you have a battery that in some points when you're transmitting, you might have current going one direction, and when you receive, it's going the other direction. Just take 2 of them and put them back to back. So now you'll see in one direction, and you'll see in the other. Okay, so the different parameters that you'll see, one of them is the capital letter A with a small p, and that's the amp peak. So what that's going to tell you is as you're operating your radio station, and when you key your mic, that's going to be the peak load that your station is requiring. And that's kind of important when you start thinking about sizing a battery, is how much power would I need. Next is going to be a voltage minimum. Okay, so voltage minimum, what you're really interested in voltage minimum is what's the lowest when I key my mic that the voltage goes, so my radio is safe. If I'm on solar power and using the battery, I might have to turn down my power a little bit if I'm getting close to 11.7 too many times. Okay, there's a watt peak. It's a large W with a small p. And one that's very helpful is amp hours. That's showing how much energy, how many electrons I'm putting into my battery, how many I'm pulling out. That's very helpful when we're talking about batteries. And then there's also watt hours. So this was just talking about the source side and the load side. And the amperage needs of your radio, you would hook that up. Now, what I would like to do is we're going to just see what the needs are for this Kenwood TMV7. And would you want to come up just for a second here? So what you're going to look at here is the amps. So it's on receive. And what do you see right there?
It's 0.47 amps right now.
Yeah, so 0.47 amps. So now what I can do, sorry about that for a second. So what I can do is I'll have it on low power. KB7RHI testing. What do you see there?
About 3 amps.
Okay. We're going to go to medium power, I think. Let's see here. There's medium power. KB7RHI testing.
4.2 amps about.
KB7RHI testing.
8.3 amps.
So 8.3 was the peak. Now the battery I'm using right now is a 12 amp hour lithium iron phosphate battery. And let's go ahead and let's say there was an emergency that happened and I wanted to get 2 radios going. So I'm going to turn on my FTM400 at 50 watts. Oh, and I want to be charging something else here too. So let's go ahead and put that on. So now I'm charging my Goal Zero Lighthouse Mini, and I have this and this. And let's see what happens when you see all of that. KB7RHI testing.
17 amps.
So I have 17 amps. This battery is capable of 12 amp hours, 100% depth of discharge, and will do 20 amps continuous, and has a very flat discharge curve. Thank you very much. So now what I would like to do is I would like to take this here. Let's turn this off. Disconnect this. Disconnect this. Now what I would like to do is have you all see what this meter looks like. I'm going to pass this around the room. Let's see here. Now, if you see someone walking out with this, please slow them down. Yeah. Okay. So what you're going to see, I don't know how far I can go with this mic. I was just going to have you start passing this around, and just go ahead and look as you see the different readings, and just don't disconnect it, please, so everyone else can see. So here I was looking at just using an example. You want to know what the power needs of your station is, so check receive, low, medium, high, and anything else you might be doing, and then write those readings down. You want to have that information as we're going to be going forward and getting battery for backup. The energy needs of your radio. So we talked about the receive was the 0.48, the transmit, medium power was 4.2, and let's determine how much we would need. So if I say I have a 4.2 amp load, that's the rate, and then rate over power over time is the amp hour. So if I have 4.2 amps for 1 hour, that's 4.2 amp hours. If I have a constant load of 2 amps for 24 hours, I have 48 amp hours. Now, one way you could do an estimation, and this is just a ballpark estimation, is if you had a load of maybe 10 amps for 30 minutes and 5 amps for 30 minutes, you'd have an approximate average overall amps of 7.5. But with our radios, do we just talk 50% and listen 50%? No, we talk a lot less and listen a lot more. So what we can do is kind of do a weighted average. So what I have is 10 amps. First is just showing that the math works. So 10 amps, 50%, 5 amps, 50%, get 7.5. Now let's say we listen, the R with the little X, 90%, that's received, and I talk for 10% of the time. So my received current was about 0.48 amps for 90%. So the weighted average is 0.43. And then my talking, let's say I was on medium power, 4.2 amps, 10%, 0.42. I add that up and I get 0.85 overall average amps per hour. And if I did that for a 24-hour period, I get about 20.4 amp hours that I would need from my battery every day. Now with solar power, I can provide quite a bit during the daylight, and then when the sun goes down, I got to have the battery big enough till the sun comes back up the next morning. So the voltage range for our radio, 11.7 volts to 15.9 volts. The peak amperage, 8.4. Energy, 20.4. Next, we're going to go to some battery basics.